Okay guys, this is part 2 of the trig introduction for 10A part 2. And we went over already in the first part of this video, in the first part of this trig introduction, and we talked about how trig uses theta for its variable. We also went through how the correct way to label the triangle sides for this unit in trig. And if you haven't watched that video, be sure to go back through it. This section on labeling the sides is really the foundation, and if you don't completely understand that, you really do need to go back and review that video. Alright, so when we do trig, we're going to use some functions, and they are called sine, cosine, and tangent. These are the main functions in trig. And really, they're based on the relationships that exist between the sides of the right triangle. There's those sides of the right triangle that we just learned how to label. Here's theta. Opposite to the 90-degree angle is our hypotenuse. And we always just label that H. The side that's actually touching theta, as you guys will remember, we label that A. That's our adjacent side. Then all the way across the triangle is our opposite side. So when we're looking at these trig functions, we also want to remember that they are most frequently just abbreviated with the first 3 letters of their name. So when you see the word, if you see this, you're going to say that sine. And of course, that's not how sine is often spelled, but this is how sine is spelled for trig. And this is how we write it, just S-I-N. And then cosine, we just write C-O-S, but we say that cosine. And then tangent, same thing, we write it T-A-N, but we say it tangent, okay? Now, we have a little trick to remember the relationships of these functions with the sides of the right triangle, and we just say this Sohcahtoa, Sohcahtoa, okay? And sometimes you'll see it written like this. I like it when it's written like this, and this is why. When we talk about the sine, we're talking about the sine of a specific angle. And in this case, we're talking about the sine of theta. Well, that didn't really. The sine of theta. Okay? So that's the sine of that angle. It's with respect to this specific angle. Okay? And it turns out the sine of theta equals opposite over hypotenuse. So the sine of that angle is the length of the opposite side over the length of the hypotenuse, okay? And here in Sohcahtoa, you'll see that relationship. Sine is opposite over hypotenuse. If you see it this way, these are not placed one above the other, but you can remember because the O is first, sine is opposite over hypotenuse. What about cosine? Well, cosine, again, also with respect to theta, very specifically. When we're talking about trig functions, they are with respect to a very specific angle. The cosine of theta is equal to adjacent over hypotenuse. And even in those, in the ways we label those sides, that really means the cosine of theta is equal to the length of the side making up that angle that's not the hypotenuse over the hypotenuse length, right? Because even the ways that we labeled this triangle are, again, with respect to a certain angle. Tan is opposite over adjacent. So, again, cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And this would be really good to have memorized, even if all you do is just remember to write Sohcahtoa on your paper, Sohcahtoa. I like to write it like this because it just is easy, an easier visual representation. But Again, sine is that specific ratio, cosine this one, tan this one. So just become very familiar with this table, with these relationships. Okay? And remember that the side that is opposite and adjacent depends on which angle is theta. The hypotenuse will always be the hypotenuse because that's always that long diagonal opposite the 90-degree angle. Okay, guys, make sure you're referring to this table. Take a screenshot, read it over. This is going to be really, 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 really important. So take a screenshot here because this is what you're going to want to refer back to when you're working these problems. All right, guys, thanks for watching.